block at an angle. That angle is 30 degrees. And the force of pull given in the problem is 60 newtons. We know the block that we're pulling is 10 kilograms, and there's a 15 newton force pulling back to the left. So to solve this problem, what we need to do is figure out, well, which way is this accelerating? It's going to accelerate directly to the right, because that's the way you're pulling it. It's not accelerating up, it's not accelerating down. So it's going to accelerate to the right. So to find our acceleration, we're going to add up our left and right forces. As always, I'm saying to the right is positive, and I already drew the components of the force of pull. I got the force of pull in the x direction to the right is in yellow, and force of pull going up is in blue. Now we don't need the blue one right now. We're not worried about the up and down because we're not looking for the normal force or anything. But if we were, we would add up the normal upward, force of pull y upward, and gravity going downward. And those would all add up to be 0 because it's not accelerating in that direction. But we'll just worry about left and right for right now. So pulling to the right, I've got my force of pull in the x direction. And I do have a force going left, which is my force of friction. I'll say minus force of friction. I'm out of forces, so that has to equal the mass of the block times the acceleration of the block. Now we're trying to solve for acceleration, so we can just divide this mass out of this term, and we'll have our equation set up for exactly what we want. So force of pull in the x minus the force of friction divided by the mass equals acceleration. Now we can plug in our numbers. Force of pull in the x is the adjacent side of this triangle, which means to find it, we use cosine of the angle itself, which is 30 degrees, times the force of pull itself, which was given at 60 newtons. And we subtract the force of friction, which was given in the problem as 15 newtons. Divide all that by the mass, which is 10 kilograms, and that should give us the acceleration. We plug into our calculator, and we should get an acceleration of 3.7 meters per second squared.